This will be part 2 of our lesson today, and we're going to skip to the real-world applications of solving exponential equations. If you need some more examples, I did post the full key on the Canvas page so that you can see more worked examples based on what we were solving before. All right, so we have 2 real-world scenarios we're going to conquer here, and also be sure and practice the ones in your homework assignment to make sure you are prepared for the quiz. So, scenario number 1, you deposited $5,000 into a bank account that's paying 6% annual interest. That is being compounded monthly. Remember, that means they calculate the interest, dump it into your bank account. Each month they do that, so you're calculating the interest on more money. How long until there is $8,000 in your bank account? Here is our compounding interest formula that we used in the last unit. And if we are ending up with $8,000, that is going to be our final amount. So I'm going to plug in 8,000. Remember, this is the final amount. P stands for principal. That means the initial investment, which our initial investment was 5,000. And R is our interest rate. Remember, we convert this to a decimal place, so I'm going to plug it as a 0.06. N is the number of times that it is compounded in 1 year. Since it is compounded monthly, that means it happens 12 times in 1 year. So I'm going to plug in 12 here and here. T is our time, and since it's asking how long, that is what we are solving for. So now we are going to use our algebra skills to unravel this equation. Our goal is to solve for T. What do we do first? Order of operations, backwards. Is there anything I can add or subtract away? Nothing to add or subtract. How about multiply and divide? This is multiplied times all of this right now. So to get rid of it, my first move is going to be to divide by 5,000. So 8,000 divided by 5,000 is 1.6. I would like to go ahead and combine this to be one number so that I can just write that as my base. So 1 plus, well, I'm just going to do 0.06 divided by 12 is 0.005, and then I'm going to add that 1 in. So it is 1.005 is what everything in parentheses would calculate to be. And it all has this exponent of 12t. Okay, so we've added and subtracted, multiply and divide. Higher up is our exponents. Now, to solve for this exponent, I need to use logs. Base of the exponent is becoming the base of the log. So this is base stays the base, the others switch place. So the entire exponent is what it is going to equal. Now, we can type this part into our calculator. And that answer we're going to divide by 12 to solve for T. So I'm going to type, I have an old calculator, so I'm typing 1.06 divided by log of the base, which is 1.005. So that is the numerator, and I want to divide that answer by 12. Remember not to round, because the more we round, the more our answer will become off. So this is 7.85. When you take the quiz, you're going to be sure and read the directions to see what it tells you to round to. This one does not specify. So it's approximately, it's almost 8 years until we have $8,000 with a $5,000 initial investment at 6% interest, compounded monthly. So that's what that answer means. Okay, last real-world scenario. Suppose the population for a city is 15,000. Using this equation, this is the equation we always use for compounding population because population is always compounded continuously, meaning we never stop to calculate how many people there are before we start collecting more people, right? We're always adding more people to our population. So we always use this kind of, and actually banking does the same thing nowadays because we have computers to do our calculations for us. They also use this type of calculation. So P of t is the population at any time. P naught, this is the initial population. T is the number of years from present time. How long will it take for the population to reach 45,000? Okay, so currently we have a population of 15,000. I'm going to plug that in for P naught. The ending population is 45,000. That's what we're trying to calculate when that population ends up at that. E is a constant. Remember, that's approximately 2.71, and it goes on and on and on. So it is a number. It is not a variable in this scenario. To the 0.04 t power. Okay, we are ready to solve for t. That is our variable. So first, I notice I have 15,000 times all this. I'm going to divide that away first. And I'm left with e to the 0.04 t power equals 3. Okay, I am now that I've isolated the base and the exponent, I'm ready to convert it into log form. Remember, log with the base of e is ln for natural log, and the others switch place. So what I'm ready to type into my calculator, I'm going to type natural log of 3 and divide that answer by 0.04, and I will have my t. So to the calculator, I'm going to type natural log of 3, which it gave me an answer, and I'm going to divide that answer by 0.04. I got 27.465. Again, it didn't tell me what to round to, so I'm trying to figure out how long. So 27 point, I'll round to 2 decimal places, 47 years is approximately how long it'll take the population to get to 45,000 people. Okay, once you've worked these examples with me, try the homework questions. I post the key for you so that you can check and make sure you're getting them right. And I will be available for our Q&A session on Wednesday at 1 p.m. if you have any questions on any of the homework problems before you take your quiz. Thank you all for your hard work during this crazy time. I can see you guys working hard. Don't think that just because I can't physically see you that I don't know you're working. I've been seeing it, and I'm really proud of you. Thanks, guys.